Good morning. Combinatorics is the study of arrangements of objects. Perhaps the first application of the study of combinatorics was in the study of gambling games. Understanding combinatorics helps us determine the time complexity of certain algorithms. Counting defines the requirements for the number of telephone numbers or the number of internet protocol addresses. Counting techniques are used extensively when probabilities of events are computed. Basic counting principles. The product rule. Suppose that a procedure can be broken down into a sequence of two tasks. If there are n1 ways to do the first task, and for each of these ways doing the first task, there are n2 ways to do the second task, then there are n1 times n2 ways to do the procedure. Example 1. A new company with just 2 employees, Sanchez and Patel, rent a floor of a building with 12 offices. How many ways are there to assign different offices to these 2 employees? Solution. The procedure of assigning offices to these employees consists of assigning an office to Sanchez, which can be done in 12 ways, then assigning an office to Patel different from the office assigned to Sanchez, which can be done in 11 ways. By the product rule, there are 12 times 11, 132 ways to assign offices to these 2 employees. Example 2. The chairs of an auditorium are to be labeled with an uppercase English letter followed by a positive integer not exceeding 100. What is the largest number of chairs that can be labeled differently? Solution. The procedure of labeling a chair consists of 2 tasks, namely assigning the seat of one of the 26 uppercase English letters and then assigning to one of the 100 possible integers. The product rule shows that there are 26 times 100, 2600 different ways that a chair can be labeled. Therefore, the largest number of chairs that can be labeled differently is 2600. Example 3. There are 32 microcomputers in a computer center. Each microcomputer has 24 ports. How many different ports to a microcomputer in the center are there? Solution. The procedure is choosing a port consists of 2 tasks. First, picking a microcomputer and then picking a port on this microcomputer. Because there are 32 ways to choose a microcomputer and 24 ways to choose a port, no matter which microcomputer has been selected, the product rule shows that there are 32 times 24 equals 768 ports. Example 4. How many different bit strings of length 7 are there? Solution. Each of the 7 bits can be chosen in 2 ways because each bit is either a 0 or 1. Therefore, the product rule shows that there are 2 to the 7th equal 128 bit strings of length 7. Example 5. How many different license plates can be made if each plate contains a sequence of 3 uppercase English letters followed by 3 digits and no sequence of letters are prohibited even if they are obscene? Solution. There are 26 choices for each of the 3 uppercase English letters and 10 choices for each of the 3 digits. Hence, by the product rule, there are 26 for the first letter, 26 for the second letter, and 26 for the third letter, or 26 cubed for the letter portion of the license plates, and 10 for the first digit, 10 for the second digit, and 10 for the third digit, making a total of 10 cubed for the second part of the license plates. And we multiply those 2 values together to get 17,576,000 possible license plates. Example 6, counting functions. How many functions are there from a set with m elements to a set with n elements? Solution. A function corresponds to a choice of one of the n elements in the codomain for each of the m elements in the domain. Hence, by the product rule, there are n times n times n, m times, or n to the power m functions from a set with m elements to one with n elements. For example, there are 5 cubed, or 125 different functions from a set with 3 elements to a set with 5 elements. counting one-to-one functions. How many one-to-one functions are there from a set with m elements to a set with n elements? First, note that when m is greater than n, there are no one-to-one functions from a set with m elements to a set with n elements. Now let m be less than or equal to n. Suppose the elements in the domain are a1 through am. There are n ways to choose a value of the function at a1. Because the function is one-to-one, the value of the function at a2 can be picked in n-1 ways because the value used for a1 cannot be used again. In general, the value of the function at ak can be chosen in n-k plus 1 ways. By the product rule, there are n times n-1 times n-2 times all the intervening values down to n-m plus 1 one-to-one functions from a set with m elements to one with n elements. For example, there are 5 times 4 times 3, 60 one-to-one functions from a set with 3 elements to a set with 5 elements. The sum rule. If a task can be done in either one of n ways or in one of n2 ways, where none of the set of n1 ways is the same as any of the set of n2 ways, then there are n1 plus n2 ways to do the task. Example 12. Suppose that either a member of the mathematics faculty or a student who is a mathematics major is chosen as a representative to a university committee. How many different choices are there for this representative if there are 37 members of the mathematics faculty and 83 mathematics majors and no one is both a faculty member and a student? Solution. There's 37 ways to choose a member of the mathematics faculty and 83 ways to choose a student who is a mathematics major. Choosing a member of the mathematics faculty is never the same as choosing a student who is a mathematics major because no one is both a faculty member and a student. By the sum rule, it follows that there are 37 plus 83 equal 120 possible ways to pick this representative. Example 13. A student can choose a computer project from one of 3 lists. The 3 lists contain 23, 15, and 19 possible projects respectively. No project is on more than one list. How many possible projects are there to choose from? Solution. The student can choose a project by selecting a project from the first list, the second list, or the third list. Because no project is on more than one list, by the sum rule, there are 23 plus 15 plus 10 equal 57 ways to choose the project. Let me correct the last part of example 13. Because no project is on more than one list, by the sum rule, there are 23 plus 15 plus 19 equal 57 ways to choose a project. Example 14. What is the value of k after the following code where n1 through nm are positive integers has been executed? What we see is k is assigned 0, and we see successive for loops, not nested, from I equal 1 to n1, where we increment k as the only operation in the for loop. We do this n1 times, n2 times, all the way down to nm times, all successively. Solution. The initial value of k is 0. The block of code is made up of m different loops. Each time a loop is traversed, 1 is added to k. To determine the value of k after this code has been executed, we need to determine how many times we traverse a loop. Note that there are n subscript I ways to traverse the ith loop. Because we only traverse one loop at a time, the sum rule shows that the final value of k, which is the number of ways to traverse one of the m loops, is n plus 1 plus n plus 2 plus all the n sub i's all the way out to n sub m. More complex counting problems. Example 15. In a version of the computer language BASIC, a very early version of BASIC, The name of the variable is a string of 1 or 2 alphanumeric characters where the upper and lower case letters are not distinguished. An alphanumeric character is either one of the 26 English letters or one of the 10 digits. Moreover, a variable name must begin with a letter and must be different from the 5 strings of 2 characters that are reserved for programming use. These would be reserved words. How many different variable names are there? Solution. Solution. Let V be the number of different variable names in this version of BASIC. Let V subscript 1 be the number of these that are 1 character long, and V2 be the number of these that are 2 character longs. Then by the sum rule, V is equal to V1 plus V2. Notice that V1 equal 26 because 1 character variable must be a letter. Furthermore, by the product rule, there are 26 times 36 strings of length 2 that begin with a letter and end with an alphanumeric character. However, 5 of these are excluded, so V2 is 26 times 36 minus 5, or 931. Hence, there are V equal V1 plus V2, 26 plus 931 equal 957 different variable names for variables of this in this version of BASIC. The subtraction rule, inclusion and exclusion for 2 sets. The subtraction rule. If a task can be done in either of n1 ways or n2 ways, then the number of ways to do the task is n1 plus n2 minus the number of ways to do the tasks that are in common to the 2 different ways. How many different elements are in the union of sets A1 and A2? Well, what we do is we take the number in A1 and A2 and we say that it's equal to the number in A1 plus the number in A2 plus, and we subtract out the number in the intersection of A1 and A2. So if the 2 sets are disjoint, it's our simple addition rule. But if there's any union between the 2 sets, then we have to subtract out the intersection, or the number in the intersection. Example 18. How many bit strings of length 8 either start with a 1 bit or end with the bits 0, 0? Solution. We construct a bit string of length 8 that either starts with a 1 bit or ends with 2 bits 0, 0 by constructing bit strings of length 8 beginning with a 1 bit, or constructing bit string of length 8 that ends with the 2 bits 0, 0. We can construct a bit string of length 8 that begins with 1 in 2 to the 7th or 128 ways. This follows by the product rule because the first bit can be chosen in only 1 way and each of the other 7 bits can be chosen in two ways. We construct a bit string of length 8 that ends with 2 bits 0, 0 and 2 to the 6th equals 64 ways. This follows by the product rule because each of the first 6 bits can be chosen in 2 ways and the last 2 bits can be chosen in only 1 way. Some of the ways to construct the bit string of length 8 starting with 1 are the same as the ways to construct a bit string of length 8 that ends with the 2 bits 0, 0. There are 2 to the 5th equal 32 ways to construct such a string. This follows by the product rule because the first bit can be chosen in only 1 way. Each of the 2nd through the 6th bits can be chosen in 2 ways, and the last 2 bits can be chosen in only 1 way. Consequently, the number of bit strings of length that begin with 1 or end with 0, 0 equals 128 plus 64 minus 32 equals 160. And we'll stop there and continue.